My talk is actually going to be around networking as code from metal to mesh and everything in between. And the inspiration behind this talk really comes from one of my previous talks, Network Engineering Goes DevOpsy, because there were a lot of patterns that flowed from 20 years ago of networking all the way to today. And I also realized that we needed to see some of this in reality. Like it was great to talk about it, but we also needed to see all these different pieces and what we'd have to consider to really treat our network as code. And that can mean a lot of different things, but I wanted to give the backdrop of the fact that we do this because we want to centralize all of our activities in terms of configurations. And we likely would use something like Git or specifically GitHub or GitLab to be able to do so. But that drives a lot of consistency, which also drives the ability to do scanning and making sure of the fact that whatever you decide to program for your network won't introduce vulnerabilities into your environment. The other thought around it is, okay, if I'm using Git, could I use the principle of GitOps? And we'll talk a little bit about that as we go along. But let me go ahead and introduce myself. My name is Marino Wijay. I am a platform and developer advocate at Solo. I've been around Solo for about a year and some change, probably getting up to a year and a half now. And I'm really excited around what we're doing here for application networking. And I'll also talk a little bit about that later on. I'm also an organizer for a conference called KubeHuddle in Toronto that's happening in May of this year. So if you're interested, go over to kubehuddle.com. And I'm also part of an open source community called EddieHub. And that open source community, there's a lot of people that join and they want to learn more about open source. And I'm one of those folks. I want to join and learn more about open source and be able to contribute. But two, there are a lot of folks that are new in the world of tech. And so what I do is I'll provide my guidance around what my path was and give them thoughts and ideas as to how they can start forming their paths as well. There's a project that I'm running called 70 Days of Service Mesh, where I dig into various aspects from introductory stuff to very advanced topics within Service Mesh. So go check it out on GitHub. You're welcome to follow me on Twitter if you want. Also, a big thank you to Eric, because Eric, if it wasn't for you to reach out to me, and have that confidence and believe in me, I would not be here. So thank you so much for giving me this opportunity to come up and speak on the big fix. So I want you all to, imagine an OSI model for a second. And actually, I won't do that to you. But this is what it actually looks like today. And it's not different. And in fact, if you are a network engineer or a security engineer, you might be familiar with the TCP/IP model. They're very similar, but the OSI model actually gives us a very clean way to basically determine what's going on as packets are moving around the network, as I am forming a connection to a website. And it's very telling as to what technologies map to this as well. So I'm looking at this from the lens of the cloud native ecosystem and also with the backdrop of Kubernetes, because today everything that we do revolves around the world of Kubernetes. And so you'll start with this physical layer, and then you'll work your way up to a virtualization layer that allows you to just commoditize a lot of your existing resources. But then once you get there, there's so much you can do. There's so much you can cut up your resources to be able to run different kinds of apps, different kinds of functions, different parts of your fabric that support your network. And the possibilities become endless. But we need a model to be able to think about where all of these different tools and systems exist. So this should give you a good idea of how that all comes to be. But one thing I will point out is how do we configure this all? Because when you think about the fact that there are so many different areas of the network to configure, like the cloud, your data center that you might still operate, or maybe you've investigated edge computing, or you're doing some IoT, or you have remote workers or something along those lines, that networking actually becomes very complex. And so being consistent with using something like Git or GitHub, using version control, actually allows for you to drive a consistent set of configurations for your network throughout all those layers. In some areas, like let's say the micro edge, you may not need that many layers. You may not need that many layers to actually run. You might need less. You might need just a few components of that OSI stack to be able to proceed. When you're thinking in the cloud, though, I mean, you don't actually have access to a lot of those devices, because here's what happens: the cloud provider gives you access to infrastructure, but not necessarily the underlying infrastructure. They're saying, here are the keys to basically go build whatever you want, in the confines of what we tell you you can do, and you can go do it. You're responsible for whatever you build. You're responsible for the security aspects of it. If you're deploying containers, maybe you want to make sure you're using some sort of container scanning system to ensure that you're not pulling down malicious containers or something along those lines. But the consideration here is that there are various areas to configure in terms of networking. And so when you think about many years ago, the network looked like, okay, I had to configure my fiber channel storage. I had to configure my firewall. I had to set up security in the form of access control lists. I also have to set up my routing. And oh, by the way, I also need load balancers because I want high availability. But these were all individualized components. You would go to different vendors to source all of the different components together. And then you'd be like me, the network engineer that would hop on my laptop, do everything in Notepad, and then forget I stored it in some random folder on my laptop. And then I try to figure out where it is, but I never can find it again. So I just log into the switch and then download the config again. And that's my new config. And then I modify that or whatever I do. But the idea is that we don't want to do this anymore. And I think we're in this space where we've actually stopped. But to give you an idea of, if we didn't stop this nonsense, this is where we would be. We would constantly create, what's the word I'm thinking of? Technical debt. That's the word. We'd be creating technical debt by just forgetting about the problems that we have, sweeping them under the rug, and, providing a wrapper around it.
Please disperse! Nothing to see here!
Example of this, SDN. We just decided to mask the fact that, hey, we have spaghetti going on in our data center. SDN will fix it. Software-defined networking will fix it. But no, not really. And then you started to see the fact that if we had a version control system about 20 years ago, this would have been so much more achievable. The point I'm trying to illustrate here is that the consistent aspect of it, the fact that we can use version control. I will write my config or my code on my laptop and then use something like VS Code because that's where I'm writing all my stuff. And then I will push it up to a repo somewhere where that repo can provide. It could be public, it could be private, but if it's public, then everyone else can learn from it. Everyone can see how you're building out your network as code. But what is network as code? Like, I dropped it so many times, and it's just, what is it, right? This is network as code. So imagine if you were provided a set of servers, an API, access to your Pixie environment, for example. You could construct a YAML configuration that basically will allow you to configure your bare metal servers or even your cloud environment to give you enough that you have an operating system up and running. That operating system now is fully functional, and if you want to, you could start deploying additional artifacts on top of that. But everything that you would do through the click motions could actually be translated into YAML. I mean, YAML is my flavor. It could be anything else if you really wanted it to be. But the idea is, if I can start defining layers of my network in YAML, this now allows me to start defining my network as code, environment as code, infrastructure as code, but specifically my network. It's a small portion of it, of the entire, stack, the entire application. But that network as code becomes powerful because we also want to look at it from the lens of GitOps and desired state. But let's kind of finish this for a second. So I've decided, I'm going to go ahead and configure a physical bare metal server with Ubuntu, and then prepare it for, being able to deploy Kubernetes after the fact. But oh wait, this is just the physical server. What about the network? The physical server still has to connect to something. I mean, you can't just drop it somewhere and then expect it to kind of do its thing, right? So if you think about physical routers and switches today versus 20 years ago, they didn't really offer up an API that you can connect to be able to configure those programmatically. In fact, you actually would have to take a console cable and connect it right into that switch or that router, configure that switch router, and then do this 100 times over, which is actually painful at scale, because if you make a mistake somewhere, not realize it, you might have 2 switches with the same configuration. You might have 2 routers with the same configuration. You might have switches and routers in subnets or in mismatched subnets, and that might cause connectivity issues. This is because we've been doing things manually, connecting manually, and not really treating this as code in version control. Once we've gotten past this phase, right, and I'm actually not going to talk about these 2 layers because it's assumed that you're either going to do something like bare metal, or you're going to do virtualization because maybe you want to chop up your resources and do it that way. You don't necessarily need to, but there are a lot of different ways to be able to achieve the same goals of deploying apps on Kubernetes. Virtualization happens to be one of them. But I won't necessarily talk about that, because one of the things that you might have seen is I actually used a cloud config in my last slide there. And that cloud config, while it is applicable to Linux, the same principles will apply to your cloud environment too, which allow you to then configure your cloud environment to do additional things, like actually build that virtualization environment. But the odd thing is that virtualization environment is already there. You're deploying instances in your provider of your choice, like Civo or Amazon, or AWS, whatever it is. So I leave that out because it can be optional, it can be tunable, and there are so many artifacts out there to be able to decide how you want to go about configuring that. Once you get past that, and I will be honest, I wanted to put all of these YAMLs all over the screen, but I decided not to because I didn't want to pollute the screen. But I wanted to give you and paint a picture of what else you would need to configure, either with YAML or Helm, or even just through some basic bash if you really wanted to. Once you've gotten past that operating system phase, you've actually built out the operating system and it's ready to go, you're going to want to consider that you're going to deploy Kubernetes. You're going to want to consider that you need to have a container runtime interface on top of that to be able to just load up containers and then run them inside of Kubernetes. And then you'll get to a point where you realize, okay, this is not going to work at all if I don't have a container networking interface. And that's just the reality, because guess what? No CNI, no core DNS, no DNS, no one can talk to anyone and no one can discover anyone else. So you deploy this CNI or this container networking interface through whatever preferred method that you want. You could use bash, and the CNI is CTL. For example, Cilium CLI is a perfect way to maybe use bash alongside that to be able to deploy Cilium in a very simplistic manner. When you think about the CNI configuration, it's one thing to deploy the CNI, but you actually have to configure it after the fact. Because the CNI, if you look back at my previous diagram, like way early on about the OSI model, that CNI actually is a switching layer for your pods, your containers inside of Kubernetes. But that switching layer doesn't have all the features that you need. I mean, it provides the in-cluster switching and routing for all of, basically what that means is pod-to-pod connectivity, but it also provides layer 4 network policy, even layer 3 network policy. So, all right, you've gone ahead and deployed, your core infrastructure bits. I'll come back and hit up service mesh in a second. And now you're ready to deploy your layer 4 network policy to just basically say, okay, this can't talk to this. But what, you can't just simply deploy a network policy, right? You can't just assume that X is going to talk to Y, but X can't talk to Z. So what you actually should be doing, and this will also apply to the layer 7 auth policy, is considering the fact that you need to do some sort of profiling. Now, there's network profiling, there's process profiling, there's so many different kinds of profiling you can do. But in the lens of who's talking to who, it's more security profiling. You're trying to understand your traffic patterns so you can establish a baseline set of security policies. That baseline basically says, for the given period of this last hour, or maybe 24 hours, here's who was talking to who at the layer 4 level. So now you've decided, okay, let's apply an allow nothing policy that says no one can talk to anyone. And then we incrementally start using this layer 4 network policy capability to unlock this, to basically say we can incrementally allow A to talk to B, B to talk to C, C to talk to D, etc. However, this is just at the IP and DNS layer. And we can't just stop there, because the reality is there are some underlying challenges to consider, especially with the kind of CNI that you're using. So there's an interesting phenomenon that goes on around pods and IPs, and how often a pod IPs or a pod's IP gets released back into the pool of available IPs, an IPAM thing. Now, there's a very small potential window, and I'm talking about this because it's something I heard. It's actually something I witnessed in a talk in Cloud Native Security Con. But there's a small window where there's an opportunity for another pod to consume that same IP if it gets released back into the pool. And so there could be some trickery that's involved. This new pod can actually pretend to be another pod. And so you start to realize that there are a few things that you have to address. Locking down your CNI, which is essentially like locking down your switch. And what that entails is basically ensuring that you're tuning your CNI appropriately so that, let's say, a pod disappears. That IP should not be released back into the pool for a period of time. Once it gets released back into the pool, then we've passed this timer where we don't even have to worry about some sort of malicious activity where someone in a pod impersonates another pod. So this is all actually tied back to this idea of identity as well. And the way we can address identity is using this concept of certificates. So you have this trust, and I'll simplify this as much as I possibly can. You have this trusted entity that says, I will provide you a certificate so that you can identify yourself to someone else. And at the same time, you can use those parameters to allow someone else to identify themselves to you, vice versa. So now you have this mutual authentication going on. And that's an artifact of using identity to, obviously authenticate someone, but that's an artifact of a service mesh. Because a service mesh is another layer, another networking layer that sits atop of the CNI layer. Because you start to realize that even though there is traffic going on these various ports, the traffic actually is doing something. There's actually something going on between these endpoints. Service A is making a request out to service B, and then service B has to provide a response. But we need to authenticate these two services to be able to talk to each other, because they need to trust each other. If I have a service talking to, a non-trusted service, who's to say that the data that we get back is actually authentic? And that actually becomes a problem. And so this is where the identity piece really comes in, because as long as we can authenticate appropriately, then we will be good. We'll be fine. But then here's the other thing too. Okay, I'm allowing you through the front door. What can you do once you're through the front door? And this is where authorization comes in. So you have this auth N, and now you have auth Z. And auth Z is really about, what can you do once you enter my house? What can you access once you enter my house? What kind of actions can you take? Can you go upstairs? Can you go cook in the kitchen or something along those lines, right? And obviously, maybe when you have guests come over, if they start, opening up your fridge and pulling out ingredients and pulling out pots and pans and cooking for you, awesome, great. A lot of other people may not allow that, but that's the idea, right? In terms of authorization, what are you allowed to do once you're through that front door? We're talking about security. Now we're switching the conversation back to networking. How do we get through the front door? Once we are through the front door, how do we know where we get to? And then, hold on, we need to throw in some old school networking in here as well, like BGP. Now, when you have services running inside of your environment, and you've exposed them through a load balancer or something along those lines, one of the things you may want to do is, and this might be just an internal thing too, because you might have a massive global scale network that's internal only, you may want to consider advertising those networks out to other parts of your massive wide area network. And so BGP can show up as a recurring character inside of your YAML configuration. BGP can show up inside of Kubernetes, and that's perfectly fine. But it's now really showing you that, hey, all of these different configuration files written in YAML, written with a little bit of Bash, a little bit of Helm, can actually construct, a full network and this was all code. Yeah, I might need some hardware somewhere, but wait, if you decided you wanted to do this just simply inside of a virtual machine with like Vagrant or something, you absolutely could do so. You could simulate all of this. You could deploy a Linux environment. You could deploy Containerd. You can deploy Kubernetes. You can then deploy Cilium. You can deploy the Istio service mesh. And then you can, if you wanted to, deploy like kuberouter or a bird or something like that, and establish some BGP peering with upstream networks. And this can all be written as code. What that means is you're never having to jump through a multitude of devices to get this all working. And what's really interesting is if you actually push this all to Git and then decided, hey, maybe I want to use like, the GitOps model, what that means is, let's say you add in new entities, new resources, new services into your environment, a new app into your environment. Do you actually go right into the network policy inside of your cluster and modify your network policy to allow or disallow? Do you also do the same for your layer 7 authorization policy? No. You actually hop into your Git version control system, make those changes there, and your GitOps model, the operator that you're using, actually will pull that configuration down because we want to maintain that desired state. So what this actually drives you towards is not only consistency, but the fact that you actually limit your interface with the actual clusters that you run your apps on, which actually removes any sort of surface area of attack altogether on that cluster. You're actually removing the unnecessary access. You're actually implementing RBAC because now you don't have to engage with the cluster and even potentially compromise it. You do this all through Git. So what's the right network stack? The right network stack actually is comprised of a lot of different things, right? This is just my perspective, but you're feeding in YAML, you're feeding in code, and you're getting an application that comes out of this. You're getting the observability you need. You're locking down aspects around authn and authz, and you're able to route to all your resources. And tools like Istio, the service mesh, the Cilium CNI, Kubernetes, Containerd, whatever type of architecture you're using for your CPU, this is all possible today, right? And I paint this as a picture because you're not limited to just this, right? You could still do this all on the physical network. Why you would want to is beyond me. I mean, it would be very painful to try to do this all manually, but we've exposed APIs everywhere. We've exposed APIs, at a Cisco Nexus switch layer. We've exposed APIs through the Istio layer. Cilium offers an API. Kubernetes is offering you an API. You can do whatever the heck you want at this point. And that's important because, going back to it, if you're a network engineer, you don't have to sit there and plug your serial cable, console cable in there anymore. Learn a little bit of YAML, learn a little bit of Python, and you'll be able to configure your network as code. Now, one more thing I will point out, and I kind of have to plug a little bit of what's gone on with the service mesh world, is that there's actually an interesting paradigm shift and more of a cyclical pattern that has reoccurred. So service mesh still will be the same. There's nothing different about the Istio service mesh today, other than the fact that we've dropped the sidecar where you don't need the sidecar anymore. Now, there's an interesting pattern that has gone on here. This layer 4 proxy that you're seeing here is actually a layer 4 router. It's receiving connections, it's understanding things at the TCP, UDP layer, and it's just routing traffic, and also at the same time providing encryption capabilities. But when you start to need things like layer 7 authorization, you want to allow HTTP GET but deny HTTP delete. Well, that's where you deploy that layer 7 proxy. So the patterns that we've seen inside of a physical network have made its way into the world of application networking. So I want you all to follow along, right? I've actually created a little bit of a GitHub repo where I've actually started to populate different kinds of configs and then give you a sense of how you can start from nothing to bare metal to getting actually a network stack up and running all the way up to service mesh. And the idea here is to really help you think about what your network could look like and how you can lock that down from a variety of perspectives. Like, you're locking it down from who has access to what, You're locking it down from the element of which services are talking to each other. And at the same time, you're driving consistency. And I actually threw up Argo there as well, because that would be the preferred model to use GitOps to make your desired state changes to your network. When you deploy an app, a new app, especially into an already existing network stack, well, once you deploy it, you should also be able to deploy the policy alongside it. And this should be instantaneously available for you when you start looking at your apps. So with that, I just want to say thank you all so much. There's so much more that I could have shared, but I only had half an hour. I wanted to dig into so much more. If you want to dig into some of these technologies at a deeper level, Solo offers up some great workshops. Academy.solo.io, go hit it up. And I did share a little bit about ambient mesh. I didn't go into a lot of details because I really wanted to provide more of a perspective of networking as code and some of those paradigms and those cyclical patterns that we've seen. But you want to read more? Go hit up that QR code and download the ebook.